All right, so we're going to take a look now at a slightly different way of thinking about simulation. So far, our examples have been object-oriented, where we're defining a class and creating objects that way with array lists and things like that. But it's also possible to think about simulations in a tile-based or a grid-based kind of way. And what you're seeing here is kind of like a forest fire simulation. The idea is that you've got trees and you've got ground, and then a set of rules for how that fire can spread. We set fire to a single pixel, and then the fire spreads through this simulated forest. This comes originally from James Gleick's amazing book, Chaos, if you have time to read that. It's incredible. It's really great. The citation for where this algorithm comes from is a little trickier to kind of hunt down, but its rules are really simple, and yet it produces these really interesting organic looking kind of patterns and movements. It's meant to simulate a forest fire, but this also looks a lot like fungal growth or something like that. And the same idea for working with a grid. In this case, we're working with pixels, but you could work with a coarser grid. Actually was really great for things like terrain generation, generating landscapes, stuff like that as well. So let's get started, and we're going to code this example together. So I've kind of just created a template for us to start here. So there's a lot of ways that we could kind of approach something like this, and you could kind of do this in a simple way. You could obviously expand this to be in an object-oriented kind of approach as well. But for this case, I think I just want to create a couple of variables that define the different types of terrain that each pixel can have. So the pixel could be ground, and I'm just going to give that a number of 0. And the reason I'm making these variables is it means later it's going to be easier in my code for me to identify what's going on. I can call it ground instead of the number 0. It's just easier for me to keep track of, and I think easier to read. So we want ground and we want trees. And then the last type of terrain is if the ground is burned. And I'm going to make this -1. You could kind of make this whatever you want. And then let's go ahead and define some colors now while we're at it, one for each. So I'm going to say ground color. And I've already picked out some kind of nice colors here. So let's see, 65, 35, 0. That'd be like a brown. Tree color is going to be 60, 150, 50. And then the burned color. And again, we could do this in a class where this is all defined, but I think this is pretty easy. And then the last thing we need to do is store our terrain, our tiles. In this case, it's the pixels, but it's going to be a little easier if we work with an array. And actually, this is going to be a 2-dimensional array. So we'll have the rows of pixels and the columns of pixels, and this will be our forest. So these are all the variables we need actually to run the whole thing, which is really cool. I've got my size already set here. This will scale to fit the size of the screen. I'm also going to turn on no cursor. This is a really simple change, but makes a difference for these kinds of things. It makes it run really nice and look good. And then, so the next thing I need to do is initialize my forest. And we just want this to be a blank integer array that's height and width. These dimensions could be swapped if you want, but you'll see in a lot of examples online, and I think it just kind of, to me, makes sense that we store everything in rows, and then those rows work their way down. So width or height first, and then width. And then we can use 2 for loops to kind of create a random forest. So y is 0, y is less than height. This should all kind of make sense by now. So we're just walking through that forest array. And then we want to randomly decide whether this is going to be a tree or the ground. And so we could say if random between 0 and 100 is less than. Now we could, I lied, actually, we need one more variable. Well, we don't need it as variable, but it'll be nice because we can change it really easily. And we can call this tree density. And this is going to be essentially the chance that the terrain is a tree or is the ground, or in this case is the tree. So 60% chance it's a tree. This will be a number between 0 and 100. And this will let us really easily change this value and see how it affects the simulation. So if it's less than this random number, then forest y x equals tree. And you can see here where this variable then is really helpful. Instead of having to give it a number, tree is 1. Instead of giving that number and then we have to keep track of what is what, we can just say tree and it makes it so much more readable. Otherwise, the forest is going to be ground. And so this just initializes our array to being randomly forest and ground. And before we do the burning simulation, let's go ahead and just draw this on the screen so we can see what it looks like. So we're in our draw loop here. We're going to want to say, so there's no background command because we're going to, the whole pixel grid is filled, but we're going to say load pixels. So we have access to the updated pixels on the screen, and we're going to do another for loop. I'll just grab this here. And then, so we're going to go through this entire two-dimensional array. And then when we're done, we're going to do update pixels just so that it then sets those changes. And if you remember, the pixel array is one big long list. It's not, it's a one-dimensional array, not two-dimensional. So we need to convert x and y into this one-dimensional position. So I'm going to say int position. I'm going to make a temporary variable. And the formula for that is y times width plus x. So that's our position. And then we can also grab the value, which is going to be at forest y and x. So the position will be, this is the position in the pixel array. The value is the value that's stored in that forest array. And then we can say if value equals ground pixels in the position equals ground color, else if value equals tree, same thing, except tree color. And later we'll add the burned value in here in a sec. So let's run this and just see. We should see, there we go. So this is this randomized sort of field, and we've got the brown is the darker color is the ground, and the green is the tree. And you can see my cursor is gone too, which is great. Let's add one more thing before we get started on the burn simulation. Let's make a way that we can reset it. Instead of having to start the sketch over every time, I'm just going to say anytime a key is pressed, we're going to go to setup. And so this runs the setup function up here, and it basically resets everything. And so now when I run this, if I hit the space bar, we get this random pattern. Cool. So that looks great. The next thing that I need to do then is in my setup, I want to start. So right now nothing is burning. I need to set one pixel. We could do more than one as well. I'm going to set one pixel to be on fire. That's going to be the seed for this. It's going to set off the whole process. And let's do it in the center. So I can say x is, now I could say, I want to say width divided by 2, but that's going to give me a floating point, or it could. Especially if the width is an odd number. So I'm going to convert it to an integer. And then I'm going to say forest y x equals burned. And you know, we could write this more concisely, but I think this is a little more readable for other folks. So, and I'll put a label here. This is set a random pixel on fire. Cool. So, this is all that we need actually for kind of setting this up. And but now we need to create this function that will burn the forest. So I'm gonna create a new tab. The shortcut for that is Command-Shift-T, or you can find it up here. I'm gonna call this burn. And yeah, so let's see, what do I want to do? I want to go through every pixel in my array here, and I want to do this burn function at the position. And if the current pixel is on fire, I want to set fire to its neighboring pixels kind of around it. And if it's not on fire, then I'm not going to do anything. So my burn function is going to take in an argument, the x and y position. So I can say void burn. It's not going to return any values. And I'm going to get an integer x and y coming in. So that's going to be my two arguments. So if let's start with if the pixel is not on fire, we don't want to do anything. So I can say if not burning, skip it. And there's an easy way to test this. I could say if forest y x does not equal burned, then return. Go straight back. Don't do anything. And this is a really nice way to do this because then in a minute we're going to have a bunch of if statements and things like that. In our simulation, it's not going to make a huge difference, but it would slow it down because we're executing all those commands when we don't need to. And instead, we can sort of just like skip it and go on to the next thing. So if it's not burned, we're just going to skip. Otherwise, we're going to burn neighboring pixels. So we want to be able to test to the left, to the right, up, up, and down based on our current x and y position. And so this takes a little math and a little thinking. We're going to do kind of a combined if statement. We want to know, so we can't burn ground. That's one of the rules here too. But we can burn the neighbor if it's a tree. So we want to test if the neighbor is a tree, but we also have to make sure we don't go off the edge of the screen. So if you imagine we're at x of 0 and we try to go left, which would be -1, we'd end up at x of -1, and that would throw an error. So we could, there's a number of ways that we could deal with this, but I think the easiest thing to do is just to say if x minus 1 is greater than or equal to 0. So if we're not going to run off the edge, and if forest y x minus 1 equals tree, then forest y x minus 1 equals burned. So if we're not off the edge of the screen in the left direction, and if that pixel is a tree, then we're going to set it, instead of a tree, we're going to set it to be equal to burned. And then we could do the same thing for the other direction. So to the right would be x plus 1. So I can say if x plus 1. Now we don't want to know if it's greater than or equal to 0. We want to know if it's less than the width. So if that's less than the width, and forest y x plus 1 is tree, forest y x plus 1 equals burned. And then to do this for the y, it's actually basically the same. Up would be -1. So if y minus 1 is greater than or equal to 0, y minus 1x equals tree, then we're going to burn it. Oops, y minus 1x. And then down would be plus. So if y plus 1 is less than height, tree. There we go. And that's it. That's actually all we need here. So we're, again, for every pixel on the screen, we're running this burn function, passing in the position. We could do this inside of our loop here, but it's just, I think it's much easier to read in this extra function. If the pixel is not on fire, then we're just skipping ahead. So return, you'll notice it doesn't return anything, it just goes back. Otherwise, if it is on fire, then it's going to burn its neighbors. Now, it might be that a pixel has a neighbor that's already burned, in which case it's not going to make any difference, like it's not going to be changing it. But if the next one is a tree, then it's going to set it equal to burned. Now, if we run it, we should see, I think we got, let's see. Okay, so we have something wrong here. Let's see what's going on. We're seeing white pixels. That's not, okay. So the reason we're having an issue is that we haven't added a section for what to do if it's burned. So we're going to say else if value equals burned, pixels position equals burned color. It's our last bit here. And let's see, now we should see it spreading. And eventually, because we've got this random kind of array of trees and ground, eventually it's going to reach a point where it doesn't spread any further. It's not able to spread. And you'll notice it comes and goes in speed. Sometimes it goes really, really fast because it's able to follow kind of like a chain of trees. Other times it slows down, and eventually it's going to stop. So it stopped here. And we could keep track. This would be a really good challenge for you to try. To keep track of how many pixels were burned, new pixels were burned every frame. And you can have it reach a certain state where you say if no new pixels are burned, maybe it restarts, or you set off some other event like new trees growing back or something like that would be really cool. And if we hit spacebar, it just goes back to setup, which resets all these values. So there's not a lot that we can change in terms of how this works here, at least in this setup. But this tree density is going to change that a lot. So if I change, right now there's a 60% chance of a tree. If I make it 30, you'll see it's much more ground, and actually you can barely see it spreading. If I make this 80, now it's mostly trees, and it just burns sort of in this very smooth kind of pattern like this, and it's always going to kind of run that way. So you might find there's some kind of sweet spot. I found 60% seems to work really nice. Gives you those kind of like trails and tails and stuff like that. But even changing the variable slightly from 60 to 70 really changes that behavior. 60 to 65, you get much more kind of burn. You could even try, 58. And you'll notice sometimes it's sort of a dud. It like runs and it stops right away. And you could also kind of like tune your setup to have more trees in the middle or something like that. One other thing we could try here would be to randomly set fire to more than one pixel. So let's try that. So we can say I equals 0, I is less than, maybe we'll do 6 spots. And we can just put that inside this here. Oh, and then we don't want it to be all in the center, not all in the same spot, but we can do a random between 0 and width, and a 0 at height. Now it spreads from multiple points, and you can see some of them are going to go faster than others. You could also periodically add new burn points, like lightning strikes or something like that could be really cool. And again, changing this density from 60 to 58 really changes it. Yeah, 60 really does seem to be kind of a sweet spot for that. Yeah, and again, you could use this for different kinds of generation. So this does look a lot like fungal growth, but this tile-based system really can be really powerful and really cool. A couple of things to think about. One would be, could you think of other methods or rules for generating these trees? Could you have it follow some kind of height map or something like that where they don't grow on steep slopes? Could you add wind that sort of makes the burn move more strongly in one direction or the other? Or could you add other elements to the landscape that don't burn, maybe like rocks or ponds? So you could add additional terrain values here, different colors and different things to your landscape, ways that that's generated, so that it, and see how that affects the fire. And could you maybe change these rules? Could you, for example, have it look, right now we're looking just up, down, left, and right. Could you have it look in the diagonals, or be able to go further, or have a certain amount that's burned, at which point maybe you want to move over to a class where you're sort of keeping track of stuff. But what I love about this is that the rules are really simple. They're easy to understand what's going on. But that you could keep tweaking and changing this and getting this really, really complicated kind of system. And I mentioned in the beginning that this is based on chaos theory and or from James Gleick's book, Chaos, which is really amazing. A couple of resources that are in the code, I'll put them in the links too, or in the description. One is this cool paper I found. I just kind of went and looked up forest fires. And there's a lot that's very science heavy and complicated, but I thought this was a really great and beautifully designed simulation paper on simulation from Saiful Bakori from a couple years ago, and it's got really great description of this grid-based kind of system, so you can read through, and there's some diagrams and all kinds of really good stuff here, so you can check this out. And this idea of cellular automaton actually is very much tied to chaos theory and like the history of simulation. And the most famous is Conway's Game of Life. So John Conway, who actually died just a few days or weeks ago, was a real pioneer of this. He was a mathematician based in England. And his most famous contribution, at least to people outside math, is this thing he created called the Game of Life. And the idea is here, you've got this grid, just like we do. You've got the grid can either be black or white. And then depending on the neighbors and a set of rules that you create, pixels flip one or the other, black to white. And this, I'll put this as well. This is a link from Cornell that kind of talks about the details. But this I thought was a really nice video showing this as well. And so depending on how you set this up and the rules, you can get these really complex behaviors that you would not expect. And this is the amazing part about the Game of Life. You can get, people have named these things like gliders and stuff like that, but you can get these repeating behaviors, these patterns. So here you've got these kind of flashing things that go back and forth and are sending out these little sort of like spaceships or birds. You can create more and more chains, and people have spent decades studying this and exploring and seeing what's possible from this, which is really cool. Implementing it and processing is possible, and I believe there's an example in the processing examples you can check out. Here's these like spaceship things and these like repeating patterns. It's really incredible. Another classic kind of chaos simulation is the double pendulum. And so, a single pendulum just goes back and forth in a very predictable way. But if you add a second arm, the pendulum behaves in this very unpredictable and non-repetitious kind of way. It's possible to also simulate this in the computer, or you can build one in real life. And the patterns are really, really cool. This is not a tile-based kind of thing, but chaos theory is really full of these great visual examples where you can see these kinds of results, and the computer then becomes a really great tool for exploring that.